Building a modern application with object-oriented Java on top of a relational SQL database creates a severe, inherent mismatch. The two systems organize data in ways that are structurally incompatible. Attempting to manually bridge this gap without specialized tools requires writing thousands of lines of hand-coded SQL. This process is repetitive, error-prone, and creates a layer of code that is difficult to maintain as your database schema evolves. To solve this, developers use Object Relational Mapping, or ORM. This technique acts as a translation layer, automatically mapping Java objects to database tables and ensuring data flows correctly between the two environments. While the automation saves time, the primary goal is object persistence. It allows an object to outlive the application process, saving its state to a database so it can be recreated and used again later. Hibernate is an ambitious project providing a complete data management suite. The core ORM engine is supported by utilities like Search and Validator. The suite also includes Hibernate OGM, an object grid mapper to store data in NoSQL systems instead of traditional SQL tables. Understanding this entire ecosystem is a mandatory first step. Selecting the right utility from the Hibernate toolbelt determines how effectively your application handles data throughout its lifecycle. We can see these tools in action by setting up a basic Hello World application. This starts with gathering our software dependencies using Apache Maven. In your Maven configuration, you only need to declare one primary dependency, Hibernate Entity Manager. This single declaration automatically pulls in the necessary transitive dependencies, bringing in the core Hibernate engine and the Java persistence API steps. These setup requirements are standardized in the official documentation, which provides the authoritative blueprint for Hibernate's configuration. Managing dependencies via Maven removes the risk of version mismatches between the engine and the API. By locking in these specific libraries from the start, you ensure the persistence layer remains stable as your project adds more complex features. With the libraries in place, the first logical component we must define is the persistence unit. A persistence unit pairs your Java domain model with a database connection, bridging your code and data store. Large-scale applications often require multiple units to interact with different databases across the system. For our Hello World project, we map our message class to a database table through it. This mapping tells Hibernate exactly how to translate the object's properties into table columns. The persistence unit is the load-bearing center of the system. Without this definition, application code and the database remain isolated, preventing any data storage. Once the foundation is defined, we move to the programmatic wiring of the persistence layer by loading settings from a configuration file. We start by creating a service registry. This component handles the low-level details of the database connection and manages the internal services Hibernate requires to function. Next, the metadata builder takes over. It parses your mapped Java classes and integrates them into the active system, teaching Hibernate your data model structure. This sequential wiring is necessary to convert static configuration files into a live environment that can respond to data requests in real time. Finally, using the completed metadata, the application builds the session factory or entity manager factory. Once this factory is built, the persistence layer is officially active. It is now ready to manage transactions and execute the operations required to save or load data. This brings our Hello World project to life. The message object created in Java is now successfully persisted in the SQL database, where it can be retrieved on demand. With the persistence unit defined and the configurations wired, the foundational layer is complete. The bridge between your Java code and the SQL database is now fully functional, allowing you to focus on the business logic of your application.